Hey everyone, in this video, let's take a look at question 21, merge two sorted lists on Leetcode. This is part of our blind 75 list of questions, so let's begin. In this question, you are given the heads of two sorted linked lists, list 1 and list 2, and you want to merge the two linked lists into one sorted list. You want to return the head of the merged linked list after. So here we can see we have list 1 and list 2, and here is the merged order. You can see that we could actually swap this red one with this purple one. In this case, they just did it with the purple one. So basically, here is the final answer that we get. And you can notice that in the very end, we will just return this one over here. We might have also cases where both of them are empty lists, in which case we can just return the empty list. We might also have cases where one of the list is not empty, but the other one is empty, in which case we just return that non-empty list. So even before we start off thinking about the solution, I think one thing we can automatically notice is if list 1 is not provided, then we can just return list 2, which may or may not also be null, but we'll just return list 2. Similarly, if list 2 is not provided, we can just return list 1. Okay, so cool. So how might we go about doing this problem? Well, if you think about this problem, it's actually quite similar to how you might do like a merge sort type merging, right? Like in merge sort, after you do your recursive call and you come back, then you need to basically merge your answers together. And in that one, you're literally doing the merging two arrays. The only difference is that it's two arrays and not like two linked lists. So that's like one difference that we see. Otherwise, like the logic would be the same, right? Like you would check the values. So you would check if like one value is less than the other one. And if it is, you would add that one to your list. Otherwise, you would add the other one and then you would like advance appropriately, right? So for example, if I added this one, then I would go over here now. Then if I added this one, I would go over here now, etc. So let's maybe see how we can like do this in Paint. So I can draw an example. So let's see what happens here. Go ahead and paste this in. Move this, paste this in. Okay, so as with all of our linked list problems, like we need some sort of counter, right? Like we need some sort of cur to go through the linked list. So maybe we can just call this cur1, right? For linked list 1. Call this cur2 for linked list 2. And notice how we also need like a cur to actually create this array, right? Like we need a cur to create the final linked list. We can't just keep overriding cur1 and cur2 and like we need some way to like figure out like what this final linked list would be. So maybe here I can just call this like my cur final, right? Or something like that, like cur final, let's say. Okay. So initially, what do we have? Well, initially, like cur final, what do we want to set it to? Well, cur final, we don't know what we want to set it to just yet, right? Because we haven't even done like any calculation. So why not set cur final to maybe something like, let's say we have like another node here, and this node in the start, maybe it can be something like just a temporary node, right? Like maybe like a -1 or something. So let's just say this is like a -1. And then -1, initially it's empty, but then as we go through our list, what we can do is cur final. Well, in the end, it would be like somewhere over here. But what we can do is if we have a reference to this -1 here, then we can just return -1.next. So it will return the head of the new sorted linked list. So maybe we can like start off with something like that. So we'll have cur1, we'll have cur2, we'll have cur final. So then we could basically go from there. So what do we need to do in this case? So let's see. In the start, we need to compare cur1 and cur2, right? And in the case here, let's just assume if cur1 is less than or equal, then we will take on cur1. So if less, or actually in this case, let's assume that if cur1 is less than cur2, then we will take cur1. Otherwise, if it's greater or equal, we will take cur2. Okay, so what happens in this case? In this case, we'll take cur2, right? So what we need to do is we need to, first of all, this cur final, we'll make it point, the next pointer, will go to this cur2 over here, which is this purple one here, and then we need to advance cur2, right? What else do we need to do? Well, notice how we actually advanced cur final as well, right? Because cur final was over here. We did cur final.next is equal to this cur2 here, but we also advanced cur final. So that's like three things we need to do. What about in this case? Well, in this case, we'll compare. 1 is less than 3. So what does this mean? It means that cur final, the next pointer of cur final, will point to this 1 over here. We'll advance this cur1 to 2. And then we'll advance cur final also to right here. And then we'll keep this process going. So 2 is less than 3. So again, we'll advance this, or actually we'll first make this link over here. 1 goes to 2. And then we'll set cur final.next is equal to 2 over here. And then we'll advance cur1, right? And then over here, we'll do the same thing for cur2. So cur2 will get advanced as well. And then we'll make the link, and then cur final will get advanced. And then notice here, we'll actually take, so I think they kind of messed this up, but if the items are the same, then we should be taking this purple one. But in this case, it looks like they took the red one. So basically this cur1, it will actually be out of bounds now, right? Because we advance cur1, but it's out of bounds. So before we advance cur1, we need to make this link here. We make this link, then we move cur final here, and then we move cur1 outside. So now cur1, basically this list does not have any pointers to it, right? So the only thing we have left is cur2. So in cur2, we'll basically add in the remaining nodes as part of the final linked list. And once everything is done, we have access to this -1, right? So we can just return -1.next to get this first node here. So let's take a look at how we can do this in code. So what do we need? We need like 3 variables, right? So cur1, we can set to list1. Cur2, we can set to list2. Now I need like some sort of like dummy starter variable, right? Like to hold this like -1. So maybe I can just do that. I can do like dummy is equal to list node -1. And then I need something to like actually create the final list. So I can do like cur final dummy, right? And now what do I need to do? Well, now I can loop, right? So I need to loop while cur1 and cur2, right? In this loop, I'll have access to both of the elements. At one point, there'll come a time when I don't have access to one of them, right? So then we can go outside and then we can handle that separately. But in this case, let's assume we have access to both of them. Then what do I check? Well, I can check if cur1.val is less than cur2.val. If this is the case, then what do I want to do? Well, I want to set, first of all, this cur final, right? Cur final's next value should be cur1. What else? Well, I need to advance cur1, right, to cur1.next. But I also need to advance cur final now. Cur final now, initially, it was something else. Now it should be equal to cur1. So now I can do cur final to cur final.next. And we'll repeat this for the other case. In the other case, we'll do cur final.next equal to cur2 actually. We will advance cur2. And then we will do cur final is equal to cur final.next. Okay. So while we're done this part, now we're basically at the scenario where everything is done except cur1 is now outside, right? But cur2 is still here. So we actually still need to add on this 4 as part of this location here. How do we do that? Well, we can check, right? So we can check while cur1. So if cur1 still exists, then we will just update cur1 as we did over here. We will just, I can actually just go ahead and copy this. So advance cur final. Cur final's next actually to be cur1, and then I'll advance cur1 and I'll advance cur final. And then we can do the same thing for cur2. So I'll just do cur2 here. Cur2, cur2, cur2. Okay, so almost done. But what do we return? Well, we need to return the head, right? We need to return the head of this new list. Now the head of the new list was like this -1 here, right? This -1, but then it should actually be this thing here, But luckily we have a reference to this -1, right? Because it's just dummy. It's just dummy. So what can we do? We can return dummy next. And so that should return the new head of the sorted linked list. So now let's go ahead and run our test cases. Perfect, they passed. Let's go ahead and submit. And they pass as well. Awesome. So the time complexity for this one and space would basically just be O of n. Space because you're creating a brand new node, brand new like linked list array. So like that's where space comes from. But it's important to also advance this cur final, right? It kind of makes sense to advance this cur1 and cur2, but we need to make sure to also advance this cur final. So initially we're here, then we're here, then we're here, etc. Okay? Hope this helped.